Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, binary tree to DLL. So what the problem is saying is we'll be given a binary tree, okay, and we want to convert it into the doubly linked list. The left and right pointers in nodes will be used as the previous and next pointers respectively in converted DL. Okay, the order of nodes in DLL must be the same as the order of the given binary tree. The first node of in-order traversal must be the head node of the DLL. Okay, so here the so what the problem is saying is, right? So we'll be given a binary tree, right? And we want to convert into doubly linked list. Okay. So we don't, so each node in the binary tree, you know that it has left and right pointer, right? But in this particular example, they've also provided two pointers. One is previous and another is next. Okay. So what we want to do is we want to convert this binary tree into the doubly linked list. Okay. With using the same nodes, you don't have to take extra space for that. Okay. So each node has previous and next pointer as well. Okay. So we want to just iterate through this binary tree. Okay. And modify. Okay. While iterating this binary tree. Okay. Now they have also provided the hint, right? The first node of in order traversal. Okay, the leftmost node, right? This 25 is going to be the first node of in-order traversal. Okay, we'll see how it is a first node. Okay, must be the head node of the DLL. So here in the problem itself, they are like they have given the hint that we want to do the in-order traversal. Okay, so how we are going to do it? Okay, so let's see. Let's dry run. Okay, so let's say we are going to start with the root node. Okay, now since we have to do in-order traversal, so what the in-order traversal says, first process the left subtree, okay, then process the root, okay, root in the sense whatever is the root at the given point of time, okay, and then go to the right subtree. So that's what is a property of in-order traversal, right? So let's go through. So here we have the root, right? So it says first go to the left subtree. So we'll go to the left subtree, 12. So we'll check here again this. Now for example, this is the root, right? This is the root now. Now it says that we have to still go to the left. Okay. So here again we come here. This is a root now. Okay. Now 25. Now we'll try to go left, but there's no left. Okay. So we are going to return. There's no left child, so we're going to return. Okay. Now we are done processing the left subtree of this root, right? Or of 25 basically. Now we'll process the root. Now this is, as you can see, right? This is the first element of in-order traversal, right? This is the first element of the first node of in-order traversal. So what we are going to do now, okay, now we are also going to have two pointers here. One, two pointers here. One will be head and another is going to be previous. Okay. Now, when we come to the first node of in-order traversal, so first what we're going to check if now these are going to be these pointers, right? Initially they are going to be null, right? So we're going to check here if head is null, if head is null, then we are going to do what? We are going to assign whatever is the first node or root. Basically, this is the root, right? We are going to assign this as a head and previous as well, and previous as well. Okay. So now, okay. So now we are done. Now, for example, now we have processed the left subtree of 25. We have processed this root also. We have done this, right? We have done this business logic, right? Of assigning the first node head previous. For example, head was null here. Head was null. So we have pointed this, okay, the first node as a 25 and previous as well. Now we go to the right subtree. There's no right child. We'll go back. So we're done processing 25. Now our pointer will come back here now, right? Our pointer will come back here, and so we are done processing left subtree of 12, right? Now is the time to process the root. Okay, now is the time to process the root. Now what are you going to check here? If head is null or not. Head is not null, definitely. Then simply what are you going to do? So previous is this. Previous is still this. Previous is still this, right? So what we're going to do is previous dot write. Previous dot write. For example, what are you going to write? Previous dot write equal to root. Right. So what is root? Root is 12. Previous is 25. So we are saying previous dot write equal to root. So what we are saying is previous dot write equal to root. Root is 12. And root dot left. Root dot left equal to previous. Right. So it's a doubly linked list, right? So root dot left equal to previous. Okay. And then finally what we are going to do? So we are going to assign previous, we are going to assign root to previous. So previous equal to root, we are going to say. So what is root? Root is 12. So we are assigning root to previous now. Okay. So we are done with the left subtree and the process is the root, which is 12. Now we'll go to the right subtree. Okay. So 30 is the right subtree. So again, what we're going to do, we're going to try to go left. There's no left. We'll come back. Now we'll process this one. Okay. Now what we're going to say, previous dot right. So previous is what? Previous dot right equal to, equal to previous dot right equal to root. Root is this 30, right? Root is now this 30. And root dot left equal to previous. And then what are you going to do? Assign the third step, root equal to previous. So this will be previous now. Okay, so in this way, we are going to do the in-order traversal, and along with that, we are going to also modify the pointers, the previous and the right and left pointers of previous and root. Okay, so we are done processing the left subtree of 10. Now we'll come to this particular root, right? This is the root now, right? When the stack converts, this is the root. Okay, now what are you going to say? Previous dot right equal to root, that is 10, and root dot left equal to previous, right? Root dot left equal to previous, and finally we'll assign root to previous as well. Okay, so this is the intuition behind solving the problem. I hope you have got the intuition. Let's quickly see the Java code. I think you'll understand better. Before going to the code, I'll request you to please subscribe to my channel, like the video. It will really be helpful to me. Okay, so let's quickly write a util function. Okay, let's which will give us a doubly linked list, right? And we'll take two pointers, as I said, node equal to head, node head null, and node previous, right? Okay, I'll also show you the C++ code followed by this. Okay, so let's say, so let's have, sorry, so let's have this, the base condition, if root equal to null, right? Simply return. Now what are we going to do here? Okay, the general in-order traversal. So util root dot left. Okay, so once we are done processing the left subtree, that is we have exhausted the left children. So now the point, it will come here, the control will come here 25 on 25, right? On 25 the control will come here. So what are we going to check? If head equal to null, equal to null. Okay, that means head is not initialized yet. So what are we going to do? To head previous will both point to the root, will assign the root to both head and previous. Okay, if head is not null, then in that case what are we going to do? The three steps, right, which we saw here, the three steps, right? So previous dot right equal to root dot left equal to previous, right? Root dot left equal to previous, and previous equal to root. Simply we're going to do previous equal to root. And what we're going to do here, finally at the end, we are going to return head. What is the head pointer? So head pointer is going to be what? Head pointer is going to be 25. 25. That is the first node of the in-order traversal, right? So this is it. Let's compile it. Okay. What is the output here? 213. It's right. Why it is pointing out? Let's submit it. Oh, so what have I done wrong? Previous dot right equal to root dot left equal to previous. Oh, so my bad. I didn't right. I didn't mention the call, right, for the right subtree. Let's compile it. Okay, we are good now. Let's submit. Okay, the test cases are being processed. I hope you have got the solution. Please subscribe to my channel, like the video. Let's quickly see the C++ code as well. So is the C++ code the same, right? Whatever it is. So here we are checking whether if it is null PTR, right? Then simply return. Else go to the left subtree. Okay, once we've exhausted or once we found the first node of the in-order traversal, then we are going to do this step. So first time it is going to be null pointer, the head, right? And then we are going to assign root to head and previous. Okay. So once there's something in the head, we are going to do what? previous dot right, the three steps, right? Previous dot right, root dot left, and this will assign root to the previous. Okay, and then we'll also have this the right procedure of the right subtree. Okay, so this is the solution. I hope you have got the solution. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.